Hi, hello everyone. Are you able to hear me?
Yes, sir.
So today we are going to discuss, I guess, the some parts of week four was remaining, right? I guess the graph part was remaining. So we'll discuss those portions today. So we'll just wait for some 2-3 minutes more and then we'll start. Okay, so let's start today's session. So till now we have discussed for the week four, we have discussed here till the division. So we have discussed the addition, subtraction, multiplication, and division of the polynomial function, right? So today we have to discuss about the graph part. So mostly we'll be discussing regarding the graphs. How do you get to know about the graphs of a polynomial? Okay. So there are some important things that you should be knowing about the graph of a polynomial. Okay. Have you all went through the lectures, right? I guess most of you would have seen the lectures, right? So now you are already familiar with most of the concepts. Okay. So if you have to, okay. So basically, there can be a let's for example, I'm just giving you some example of a polynomial function, and you need to tell me regarding. So the while plotting any plot, like it's not about the polynomial, if you have to get an idea the exact plot, it will be difficult for you, but okay, for some polynomial you'll be able to plot that. But for some where the equation that has been given to you is very complex, it will be very difficult for you to plot, but you can get an idea regarding the polynomial. Okay. And to get an idea about, to get the brief idea about the polynomial or the you have to plot the graph. To get the graph, the first thing you should be knowing is how to calculate the x-intercept. Okay. Okay, and what is the x-intercept of any polynomial or any function? Can somebody tell me what is the x-intercept? That is basically the zeros, right? Of polynomial.
Zeros of the roots.
Yeah, or you can say the roots, right?
Can you share the screen, sir?
Yeah.
Are you sharing something, sir?
Oh, you're not able to see my screen?
No.
Yes, sir.
Okay, okay. Yeah. So is it visible now? It's visible, right?
Yes, sir.
Yes.
It is.
Yeah.
Yes, sir.
So till now, in the previous session, we have already discussed till the division part. So how do you divide any polynomial? Okay. So we have done with the addition, subtraction, multiplication, and division. So now we'll just go through the graphs. How do you plot the graph? How do you get an idea about the any polynomial that has been given to you? What is the zeros? What is the multiplicity of a polynomial that is given to you? If you have been given some sort of plot, how can you know about the turning points? How many turning points? What can be the maximum number of turning points the plot can have? Okay, those sort of things we'll be going through today. So the first thing is, whenever you are getting a polynomial equation, you'll try to get an idea regarding the roots, right? The roots of a equation or the x-intercept of a equation. Okay, roots are basically what, those points where those values of x, where if you are putting those values, the equation is getting cancelled, like the value, the basically those are the factors of that polynomial. Okay, so if you have to calculate that, what do you do? Whatever the function you have been given that is equals to 0, that is basically you need to find the factors, right? So basically factors, or you can say the point at which the function is getting 0, right? So the x value or x star or the x values where function is 0. Basically this is what you do, or you tell that as a x-intercept also, where it is cutting the x-axis, right? Or the point where it is cutting the x-axis, right? So these are basically, you say, let's for example we have a example, you can have, let's for example you have a function, polynomial function. What's the degree for, first of all tell me what's the degree for this polynomial?
6.
Degree is equals to 6. Okay, can you what can be the value if I have to calculate the intercept, x-intercept for this equation, or you can say the roots or the factor of this equation, this polynomial? What comes to your mind? How will you try to solve this? First of all, you'll take the x square as a common, right? Okay, and if you want to solve that, it will be x to the power 4 minus 8x square plus 16 equals to 0, right? So from this equation, what can be the one value that comes in your mind? That value, if you are putting in this equation, x equals to 0, right?
0. Yeah.
Right. X equals to 0 can be a one factor, and then the other you can get an idea from here. I guess this is x minus 4 ka whole square, right? So two unique factor that you are getting is x equals to 0 and x equals to 4, but the number of roots that you are getting, how many numbers of root you are, okay, that is, I guess this is x square minus 4. So from here also you'll be getting some different values, like you can get it from here x equals to plus minus 2 also, right? So basically unique, how many unique roots there are, how many unique roots you can see for this equation?
3.
How many? 3 or 4?
4.
I see 3. So the 4 roots.
Yes, sir.
No, it's 3, right? 0.
Yeah. 2 and
0
minus 2.
plus 2 minus 2.
Yeah. right? So, and if you have been
Yes.
asked, so this is same as the x-intercept you say, or the root say, you can say, or the zeros. So this is basically, this is how to solve. So the number of solutions is different, but the unique solution that you are getting is at 3, right? But how many unique solutions this equation, how many solution this equation have?
4.
Okay.
2.
It should have 6, right? The degree is 6, so it should have 6 solutions.
Yeah, it should be have, yeah, this is 6. But if you have been asked to calculate the unique, because there is a repeated
Yes.
roots, right? That is a repeated roots, but the unique
Right.
solution is 3 only: 0,
Right.
2,
Right.
and -2.
Right.
Okay, I'll come upon the multiplicity. There we'll discuss about the normal number of roots, how the repeated number, and that too also. Okay. So for this case, this is fine. If I'm giving you one example where it has been given x cube. Can you get an idea regarding the x-intercept? Just by seeing, I think so this function you will not be able to. But there are other methods also. I'll discuss upon the other methods also.
So if we get an equation like this, how would we proceed to figure that?
I'll tell you.
You can take x out, right? X out, and we can make it x minus 3 and x.
Sir,
Sorry,
we
x
can
minus 3.
solve this by
Sir, if
using binomial factoring method.
Sir, if x-intercept is -12,
X-intercept is -12. How?
sir, if I'm taking f of x is 0, then I'm able to take x common from x cube minus 4x square minus 3x. Then I shift plus 12 to left hand side, then it becomes -12, like this.
Okay, one more thing. What did I say about the x-intercept? X-intercept is basically, if I'll ask you to calculate the y-intercept, I guess you are saying the y-intercept. In y-intercept, generally, if you have to calculate, if you have to calculate y-intercept, right? Then you can directly put the value of x0, right? So in any function, you just put the value, you remove all the x, you will get the y-intercept. But if you have to get the x-intercept, basically you equate y equals to 0, right? That basically is you are calculating the root of the function. Okay, so root of the function is like those values of x where the function is getting 0. Y equals to 0 means what? You are basically equating the function to 0, right? So you have to calculate those values x where the function itself is getting cancelled, or the function values is 0, right? So for
Sir,
this plot, if you are not able to, the one
sir,
method that you can, yeah,
Sir, x-intercept is y, sorry, 4.
yeah, x equals to 4 is yeah, one value.
X-intercept is 4, negative under root 3 and positive under root 3.
Yeah, that is correct. But see, the problem here is maybe you would have solved for this equation for any type of polynomial with the degree 3, right? So the first, see, the first thing that you can solve it with 2-3 different methods. One method is like you can get an idea about the plot by just putting some random values, right? Some random values, I mean, you can get the behavior of the plot. Behavior of the plot by mean x, you can put it the x equals tends to infinite, or x tends to minus infinite, x tends to 0. Okay, those values if you are able to see where it is lying. So let's, for example, for this equation, I'll solve it. I have a 3-degree equation. If you would have read, like, the first method that you can approach is to solve directly. Okay, solving directly. See, this can be written, this is of degree 3, right? if this function is of degree 3, if I am able to find one root of this function, will that be a factor? Like if I'm able to find one root, let's for example x equals to k is one root, right? And if I'll divide this whole function by x minus k, right, because x equals to k is my root, so then whatever the quotient I'll be getting, that will be in the degree 2, right? Correct. And if I'm having an equation that is in degree 2, that is basically a quadratic equation. And for the quadratic equation, you already know how to calculate the root directly. Correct? So the first approach is to find at least one root for this equation. And that root, if you are able to find it by hit and trial, that is fine, by just putting a closer value to 0, 1, 2, something like that. But if that doesn't work, so the other method that you can approach is, the other method would be, the second method that you can think of. The first method was to just get one factor of the equation. If that polynomial is in the form of like 3 degree, mostly, because 4 degree or 5 degree, that becomes very tedious to calculate like manually. Okay, so maximum, if somebody like if that is asked in the quiz also, maximum 3 degree will be asked, because one you have to find it, and the other you can, if you are able to find the one factor, you can divide with that like the whole polynomial, you can divide with that factor and can get the quadratic equation. And quadratic equation, you already know how to calculate the equation. For the quadratic equation, for any type of quadratic equation, you will be able to calculate the root. You have the basic formula. With the factorization method also you can calculate it. Okay, so that's the, if let's for example somebody is saying x equals to 4, if he is able to find the factor, one factor, what he can do is he can just divide with x minus 4. And after dividing this whole polynomial of degree 3, you will see that you will be getting a quadratic equation. Okay, and if you'll get the you will get the quadratic equation. Let's for example, let's solve this. Let's for I'm just assuming that you are able to know that this for the first factor. And if you are able to know the first factor, you can divide it. And the division, I have already told you how to divide a polynomial. If I'm dividing it, what should be the first thing that I should be writing here?
X square.
X square.
X square I should be writing. Okay, and this would be x cube minus 4x square.
4x.
Correct? This will get cancelled. So now I'll be left with 3x plus 12. Correct? What should I write here?
Minus 3.
Minus 3. If I am writing minus 3x plus 12. So this also got cancelled. So now you can see that this basically, this polynomial is basically a product of x minus 4 and x square minus 3. Correct? This is one factor. The other would be, so the one factor you'll be getting by equating x equals to 4, and the other you'll be getting x square minus 3 equals to 0. So basically this is x equals to plus minus of root 2, right?
So, but can we use these irrational roots for plotting a graph?
So, sir, one
Yeah.
question I have, sir, if I can ask.
Yeah, you
So in the division where you have striked out 4x square,
can.
x cube will not be cancelled, right? Because it is, or that is plus or minus? Sorry, I'm
No, that would be
confused.
minus. The first sign would be minus because we are subtracting.
Oh, okay.
No,
Yeah, then it will be cancelled. Yeah, that's right.
I did the mistake.
No, it's okay. I think it's not a bracket, so I got confused. That's fine, sir. Thank you.
So this was there. So and see if so this type of maximum they can ask you of the 3 degree to calculate it, but they can give you the polynomial of any degree to get an idea regarding the behavior of the polynomial, not the exact one, but the behavior of the polynomial. Okay, let's deal with some other example.
Sir, we can solve this by using binomial factoring method also.
Yeah, factorization also will work here, because you can take x square here, because you directly see that 3 and 4 from here also you can get the 4 as a common, so you can take it something like this, right? And then x plus x minus 4, so you can calculate this, right? So from here you are getting 4, and from here you are getting plus minus root 3. Correct? And if you have to plot this, how will you plot? So this was basically, so what was the question? X cube minus 4x square minus 3x plus 12. Now we have got, what was the x-intercept that we have got? Plus minus root 3 and 4, right? How can I plot this? Can somebody help me in this plotting this polynomial? How should I start?
Place x values on the axis, sir.
That is fine. Okay, 4 is the root, and then one root would be root 3, one is 4, and one is minus root 3. Okay.
So at origin, y will be 12, the y-intercept.
Y-intercept is 12. Okay. So how should I go? Can I go directly here, or should I go here? Or should I go here? How should I start?
Sir, we should go to negative sign.
The coefficient of x3 is positive, so we should. It should be
With the endpoints.
from with the endpoint.
And behavior.
Okay. If my okay, so this coefficient is positive. Okay, fine. Then how should I start? Should I go from here, or should how should I start?
And degree is
We have to
3,
go
so
to
it should go to positive, right? So it's like going from minus infinity on the y-axis to positive infinity on y-axis as x goes from minus infinity to positive.
It will be from upward.
Sir, you should start from the first quadrant and then go towards the.
See, for this type of plot, you can start from anywhere. I'll tell you. See, so the first thing is you should be knowing how does this plot behave whenever you are putting x equals to minus infinity. So the sum of the values that you should be always trying. Okay. Like for example, for any plots, not for this plot. For this plot, so at least this is pretty simple. X minus 4, and then you have x square minus 3. This is your function. To get the behavior, just put 3 points. You should be always putting. So one is x tends to infinite, x tends to minus infinite, x tends to 0. At least these 3 you should try. If I am putting x equals to infinite, what should be the value? Function value?
Infinite.
Infinite, right? Okay, correct. If I am putting x equals to minus infinite, then
Minus infinite only.
that will be minus infinite. If I am putting x equals to 0, then
Then it will we have to put at 12.
12. Correct.
0.
Right? 12. If I am putting x equals to 0 here,
Yeah,
this
12.
is 0.
Yes.
Yeah, 12. Okay. So now I got an idea. So at least in the starting, you were checking so many things. Now at least you can think of, if I'm starting from here, minus infinite would be somewhere here, and plus infinite would be somewhere here. So I can start from positive plus infinite also, or minus infinite also. There is no problem in that. So I'll start from minus infinite. At minus infinite, my value is minus infinite, right? So it will start from here somewhere, because here also this is minus infinite, this is plus infinite. Correct?
Yes,
So I'll start from here somewhere. As we all know that minus, this is the root, so for sure this will cut here. This is cut here, or this will come back, that you have to check. Okay, so for sure it will come from here and it will go directly to here, right?
yes.
And here most important part is the multiplicity comes into factor. So this was the most simplest plot. So because we can see that for all the roots we have, what's the multiplicity for x equals we can see that what's the multiplicity, you all know, right? Multiplicity generally what is the number of repeated root at the particular point. Yeah, so repetition of that root. So for us here, what's the repetition of minus root 3? There's only one, right? So there's no repetition. Like there's, well, this is a unique root basically. So you have 3, all the 3 are unique roots. So you can say that at least the multiplicity of minus root 3 is odd number, or that is 1 basically. For all the 3 it is 1 1 1. Correct?
Yes, sir. So can you explain a little more on multiplicity?
Okay, so it's basically you have a function x minus 4, and then you have x minus root 3 and x plus of minus root 3. Correct? So you have 3 roots here, and all are having this as a because why I'm writing this? Because that is not making any difference, right? So that means what? How many unique roots you have? Okay, so the first thing is how many repeated root at minus 4, at 4 only, positive 4. How many roots of this polynomial has a
So
value
the
4?
second one should be x plus root 3. The third
Yes,
one is
sir.
x minus
Third.
root 3.
Yeah,
So
yeah,
the
correct.
So second
Correct.
and third factors are same.
Yeah. This is what. Okay. Yeah. So now I'm asking, you have how many repeated root at 4? X equals to 4 as a root.
One time.
One only. X
Yeah,
equal
if
to
I'm writing a function like this, a polynomial function x minus 4 to the power 5. Now what's the repeated root? So you have this
5 times.
polynomial function also has a only 4 as a root, but 5 times it is getting repeated, correct? There is a repetition of 4. If I'm asking what's the root of this, if you have any x minus 2 ka whole square, you generally tells, right, this function is having a root as a 2, but it is a repeated root. 2 comma 2 is the root. Basically you have a unique root 2 only, but you, as it is in the form of a square, so you say that it's a repeated root at 2. So if I'm asking a polynomial has x minus 4 to the power 5, basically you have a unique root as a 4 only, but this is getting repeated 5 times, right? So for this function, if I'm asking you, what's the, if at x equals to 0, you basically has only one root, there is no repeated root, right? So for this, what should be the multiplicity?
it's 1.
One, sir.
Yeah,
One.
1. So for x equals to 4, there is only one root at that particular point. So there is no repeated root. So you can directly say that 1. What about the root 3?
1, sir.
1.
Yeah, that is
So
1.
does repetition mean also the inflection kind of a point, like in x minus 2 whole square, it is a parabolic curve, right? So parabola will come and your vertex will be at x equal to 2.
I'll discuss that
Oh,
point also. Yeah.
okay.
So first so multiplicity part is clear, right, to everyone?
Yes, sir.
Yes, sir.
Okay. So let's one just for if I have x minus 1 square, x plus 2 cube, x plus 4. What do you mean at x equals to 1? What is the multiplicity?
2.
2. So 2 and it bounced back from the x-axis.
That will discuss it. That will discuss that. And x equals to minus 2, you have 3, and x equals to minus 4, you have basically 1.
1.
Correct? Okay, and there is one more thing.
Yes, sir.
Whenever you have a multiplicity, there is a relation. Whenever you are plotting a graph, right? If the multiplicity is odd or even number. So if you have multiplicity as odd number at some particular root or even number at some particular root, so there is some pattern in which the plot will behave. Okay, so the behavior should be, if you have odd, what should be the behavior? Can somebody tell me?
It passes through it, sir.
So it
will pass
sharply cut
Yeah, it will cut basically the
x-axis.
plot. It will cut basically the x-axis, right? And for even number, it will bounce back, right? Okay, if we are not able to understand this, we'll discuss with the plot. Let's come to the plot now. So till now I have discussed you two concepts: the multiplicity for any polynomial. If you are able to calculate the root, you should be knowing the, for each and every root you can just mention the multiplicity. If the multiplicity or the repetition of the root is in the form of odd number, you can just think of, okay, it will cut the x-axis. And if it is in the form of even number, you can just think of it is bouncing back. Let's come to the plot. Now we'll see that how does that help us, the bouncing back or the cutting of the plot. Okay, so let's here just saying you, the first thing that you should be noticing is how does this behave whenever I'm putting some infinite value and the positive infinite and minus infinite. So for this plot, whenever you are plotting, the first thing you should be doing is to get an idea how does the function behave. Just put the value of x equals to infinite and x equals to minus infinite. You will get an idea, clear cut idea. How does this function behaving at x equals to minus infinite and plus infinite? Now, whatever the nearest root is there, because if the root was here, I can't directly go there. Because we are getting minus root 3 as the nearest root from minus infinite, I'm just plotting till here. Now I told you two important things. Whenever I'm getting an odd number of the multiplicity, so what should I do? Whether it will cross the x-axis or it will bounce back.
Cross that.
It will cross.
It will cut, yeah, cross.
It will cut, yeah, because it's not x square. It's just that you have x square equals to 3. You have a root, only one single root at minus 3, and you have a single root at x equals to 3. So you have basically a odd multiplicity. If you have a odd multiplicity, it will directly go passes the x-axis. It will go till here, right? Because you already know that x equals to 0 has a y-intercept as 12. So it should cut here, right? And now you think of, you can't go directly here. So now you think of what is the next root, because I have to return back also. If there was only one root, you would have went something like this, because at infinite it was infinite. But as you all know that this function has other roots also. What are the other roots? The other root is minus root 3. So I have to go there also. I have to go there because I'm starting from minus infinite. So I should be going in some order, okay, of the roots also. Now I went there, I came here, I can go directly here also. But then again, I'm thinking that I have to go to the root again, because there is a 4 as a root also. So I have to go somewhere like this also again. Okay, and then again I'll check what is the multiplicity of the 4. The multiplicity is a odd number. That means I need to cross that. I have to cross this x-axis. Now where should I go? Should I go to minus infinite or plus infinite? That we have already known in the starting itself. At x equals to infinite, the value should be positive, plus infinite. So I have to go somewhere here. That's the positive. For infinite, the value infinite I should be reaching. So it will go somewhat like this. Correct? So the function will be somewhat like this. Is it clear? Okay. And now if I'm asking how many times this plot has a turning point. Turning point means it was going in some particular direction, but it has came back and then changed its direction. So if I started from here, let's for example, this plot has started here. This was going in some positive infinite direction, but again it has came down, right? So this is the first turning point for me. Now again the second point. Yeah, it is coming and it is going to the minus infinite, but again it has remembered that I have another root also. So I have another route. So again, it has turned its direction. Now it is going in infinite direction. So how many turning points this plot has? Two plots, two turning points, right? So one
Two turning
and two.
points.
Correct. So this was pretty simple. Let's, if you have a doubt, we'll again go to some difficult polynomial and then we'll discuss. So till now, I guess this is clear to you.
Excuse me, sir.
Yeah.
So for odd, like odd powers, odd degrees, it will bend and cross now.
Bend and cross mean?
Like it will have a small S shape and then it will cross like on the x-axis.
Okay, that depends on the number. If the values are very high, then it will bend and cross. Okay, when the odd multiplicity, but I don't think so. You have to read those things. So
Okay.
why it bends? That there is a like the there is a method behind that also, but I don't think so. You have been taught those things. So when you just have to think, whenever there is a odd, you just have to cross the line like x-axis. Okay, that depends. Whenever the x the so what happens whenever you have a multiplicity as in a higher number, then it will cross in a different like in somewhat like this. Okay, but you don't have to worry about that. Okay, let's discuss the one more example, and I'll write it here. This one, y equals to x minus, what is that example, x minus 2 whole square The multiplicity is okay. This is the polynomial that has been given to you. Okay, now the question that they're asking is the number of turning points. Okay, so and then the number of basically the multiplicity. One, 3, 5, 7. Okay, and then they're asking the function's value at infinite. Okay, this is the three things that they have asked. Okay, so to get the number of turning points, or there can be questions. See, and this question that I'm discussing is the most important part of this week. Similar question, almost similar questions can be asked in a paper also. You can be given some polynomial, you can be given a plot of the polynomial, and then can be asked information, right? For this plot, for similar type of problem, they can ask you this type of problem. They can be question where MSQ will be given, so this is the number of turning points, or that can be a maximum number of turning points. This function fx can have this number of turning points. Those type of things can be asked. They can ask you from this type of problem also. So this function, they can give you the polynomial equation, and then can ask you it is increasing from this values, and that is decreasing from some particular value. Okay, so those things can be asked in the exam. So for all those things, the best part is you have to plot somehow the graph. Okay, and if you are able to plot the graph, you'll be able to answer all those things. Okay, so
Sir,
let's
this number of turning point is 5.
I'll have to check that. We'll see that.
Yes, sir.
Okay, so for this
Okay, sir.
polynomial, so let's try to solve this question. So I'll delete this all part. Okay, those type of questions can be asked. Okay, now let's plot this. So what's the first thing that I told you? The first thing that you should be doing is, can somebody tell me what is the first thing that I told you to calculate?
Find the infinity.
Degree.
Yeah, correct. So you have to calculate first. Okay, the degree, that is fine. So multiplicity also you can check, like 1 has 2 multiplicity, 3 has 1 multiplicity, and x equals to -5 has 2 multiplicity, and x equals to -7 has 3 multiplicity. Okay, that's the first thing that you've calculated. But to get the behavior of the function, the first thing you should be doing is put the value of x
Leading coefficient.
Infinite, and then minus infinite, and then the third thing is put the value of 0 to get an idea about the y-intercept. Correct?
Yes, sir.
What is the value you are getting if I am putting the value of y equals to infinite?
Yeah, infinite only, sir.
Infinite
Positive infinite.
Infinite.
Positive infinite. Yes.
If I am putting
Negative
minus,
infinite.
yeah, if I am putting
Positive.
negative, here also positive infinite I am getting.
Yes, sir.
No, negative infinite,
Yes,
because
sir.
x plus 7 is cube.
Negative, sir. X minus 3 is the power of 1.
No,
So if this
But
is
I
a
think the
it will be
power is
positive.
even.
even. Yeah, it's even, so it will be
So
positive
that's why
only.
it becomes
See,
negative to positive.
yeah, it will be positive infinite, because you can see that the degree, what's the degree of this polynomial? I guess 3 plus 2 is 5, plus 1 is 6 to 8. Okay, so x to the power 8 is coming, right? If I'm putting infinite to the power 8 or minus infinite to the power 8, we get the infinite only, right?
Yes.
Yeah.
yes,
Or
sir, yes.
if you are not able to see from here also, you can directly put the value. Let's put the value minus infinite minus 1, or minus infinite minus 3 to the power 1, 2, because this will get positive. This is negative, fine. And minus infinite plus 5, this will be positive. But minus infinite plus 7, this will be what? Negative. And negative will make it positive. So it will be a positive infinite. Okay.
Okay.
Yeah. Okay. Now let's put the value of x equals to 0. X equals to 0, if you are putting, you'll get somewhat 1 square and then minus 3 and then 5 square and then 7 cube. Okay, somewhat like this you'll be getting, correct?
Yes, sir.
Fine. Now what's the root of this polynomial? What are the root of this equation?
Minus 7,
1, 3,
minus 5.
minus 5, minus.
minus 7, minus 5, 3 and 1.
Minus 7, minus 5.
Minus 5, 3 and 1.
1 and 3, correct. Okay, so I can start it from anywhere. Let's, for example, for the previous question, we started from minus infinite. Let's start from infinite for this question. For infinite, what was the value we were getting? For infinite, it was infinite, right? So I have to start from here. And for minus infinite, it is infinite. So I have to start from here. I have to go here, right? So start from the first, I have to go to second, because it's starting from infinite and going to infinite itself. You can see that, right? And while going from infinite to infinite, I have to go through the roots also, because this function has a root as 3, 1, minus 5, minus 7. So it should be cutting there also, right? And then in between we'll see where it is cutting the y-intercept. So that is also fine. So if I'm coming from here, I'll first cut down 3, okay? And then I have to bounce back or cut the x-axis. I'll see the multiplicity at x equals to 3. What's the multiplicity at x equals to 3?
1.
1.
It will be cut.
1. So it will cut.
1. And this is an odd number. So it'll be cutting, right? It'll cut here. It'll go
But
like
y
this.
cannot be negative, sir, right?
Which y?
Look, is the range is negative? Means can it
Range.
go?
Yeah, why can't it go? Yeah, it can go as a negative. At f equals to 0 itself, we were getting some negative value. If you'll put 0 minus 1 ka whole square, this is positive. 0 minus 3 is what? Negative. And then you have some positive square, and then you have 7 cube. So this was a negative number only, right? So that means what? At f0, it will be cutting somewhere here, like in the negative itself. Let's see that f equals to, yeah. So at 3, it is crossing, and again we have to go to 1, right? Because it should be going at 1, because x equals to 1 is the root. Now, what about the, yeah, from 1, it will bounce back, right? So this is an even number. So it will not cross, it will come here. It will come somewhere here, whatever the value f0, right? It will come here. Okay. Now from here, it should be going at minus 5, because minus 5 is the root for this equation. So it will go minus 5, and minus 5 again, it will bounce back or cut the x-axis.
Bounce back. Again,
It will come again. And at equals to minus 7, it will go and cross
It will
also,
cross.
because this is the odd number, and odd will basically cut, and it will go to infinite. Okay, what's the number of so how many times I'm turning? Like if I'm starting from here, I go like this, I turn it here, again I turn it, again I turn it. So what's the number of turning point here? The first
5.
one is here, the second one is here, the third one is here somewhere, the fourth one is here, and then the fifth one is here. So the turning point is the number of turning point equals to 5. Do you have any doubt in this solving this type of problem?
Sir, can you explain one more time turning point?
Okay, turning point, what I'm saying is, you started from plus infinite, you have to go till infinite. In between, you started from here, you have to go here. If you started from positive value, same direction, you're just following the same direction, but again you have to turn it, right? At this point, you have to, just remember that I need to go at 1. I can't go like this, right?
Yes, sir.
So this is the first the first point at which you have turned. Okay, you're just going in one direction, and how many times you are changing your direction? This is what the turning point is. The first time you have changed the direction, you started like this, you thought of going like this because you don't want to change. Then again you thought, okay, I have to go to here, right? Or from the even values also, you have thought that from, as the multiplicity was even, you already know that whenever there's a even, I have to come back. I have to come back, and then I have to return it like this. And you already know that f0 you have calculated. F0 is the y-intercept, where the value of the y-intercept. So cut down here, and again you have to go there, right? So again you can't be, you started like this, but you can't go in this direction, right? Because you already know that I have to go to -5, because -5 is the one other root for this polynomial. So I should be going here. But again here, you, as the number, the multiplicity of the -5 was even, you have to bounce back. So
Okay,
after plotting the whole plot, you can just count it how many times I've changed my direction while plotting. Okay, that's the number of your
yes, sir, got it.
basically the turning point. Okay.
Yes, sir, got it.
Now you have to give me an idea about, so let's, for example, you have been given some difficult polynomial. Okay, so fx equals to some x5 minus x5 plus 4x square
If
plus,
the graph
yeah, go ahead. Some alpha x cube and some values, and then in 5 beta. Okay, and the values is given in such a way that whenever you are putting the value of f equals to infinite, you are getting minus infinite, and when you are putting f equals to minus infinite, you are getting infinite. Okay, just listen the question. I've given you a polynomial. This is the information that you can get. Okay, this is a bit harder polynomial where you are not able to manually calculate all the roots. If you are not able to calculate the roots, this information has been given to you. Now the options are, this function fx has at most maximum 4 turning points. Okay, the second question is, okay, yeah, so tell me whether the first option has at most 3 turning points. Which of the two is the correct option?
Option 1.
Option 1. Okay, how did you came to the conclusion this? How it came to the conclusion?
5 minus 1.
What? Why minus?
I'm
not able to understand. Maybe I'm not able to hear you. So any other?
He said 5 minus 1, which is the 5 is the maximum exponent minus
Yes,
1.
sir.
That's what he said.
Okay, how you have came to this conclusion? 5 minus 1. Because here it was 8 degree, but you got as 5 as a turning point.
It was given somewhere, na, that maximum we can get at as n minus 1 turning points if the degree is n.
Degree is n, then n minus 1 turn.
Okay. Then it becomes okay. It's okay if it has been given, but from the plot also you can get an idea, because if it is starting maximum you can get as n minus 1. That is totally correct. Yeah. So that's why it has been told. So anywhere, if you're in the exam also, if you have been asked to calculate the atmosphere, do not get confused to directly start plotting that, because the atmosphere, they have just asked you what can be the maximum number of turning points. So you don't have to plot everything there. You just have to think of what's the degree, and then you can subtract it 1, and then you can get the maximum number of turning points, right? So from here also, if you are coming from here and you have to go till here, you'll be having a 5 roots, right? If you have 1, 2, 3, 4, 5, right? So how many times you are turning? So this is the 5 roots. This function can have maximum 5 roots, right? Any function of the degree 5. So this can be 1, 2, 3, 4, 5, right? And you can see the turning point. So starting from here. So this is the first turning point, second, third, and fourth. So that can be a maximum of 4 turning points, right? Correct? So just to bluff, they can give you this information also.
So can you repeat once the last one, which you are trying to tell without formula of n minus 1?
So yeah, so why? So this information was been given that if whenever f tends to infinite, our value is minus infinite. Oh, sorry, I just mistakenly plotted the incorrect plot.
It will go to second to fourth quadrant, right, sir?
Yeah, correct. So as at my infinite will go here, and at minus infinite it will go somewhere here. Okay, so it will start and you have from 5 roots. So you can think of 1, 2, 3, 4, 5 as a root. Then it'll start somewhere here. Go, because you should be having some 5 roots, right? So if you have a 5, because the all the information is not given. So if all the information is not been given to you, and if in the option it is written like at most, like what can be the maximum number of turning points it can have. So if you're starting from here plus infinite, if I'm going to minus infinite, in between, if it's a degree of 5, so there will be 5 maximum. The number of roots can be maximum 5. So the first turning point should be here, the second should be here, the third here, and the fourth here, so that the maximum also is coming to be a 5. Or you can use the formula also if you're already aware of this formula, 5 minus 1. That is also can be doable from there. It's clear, right? Okay. And in the same plot, if you are saying that the function is increasing from 3 to infinite, is this a correct statement or not?
Yeah, that's right.
That's totally correct, right? You can see that from 3 to infinite, the function values are increasing, right? For you can take any values x1 and x2, where x2 is greater than x1. You can see that the function fx2 will always be having a greater height than the fx1, right? Or that means that y value at x2 is always greater than x1. Correct? So this is a increasing function. Is it clear to everyone? All the things, whatever we have discussed today?
Yes, sir. I didn't join the beginning session. If you can just summarize all, if you're closing it.
No, I'm not closing it. We have one.
Oh, okay. That's fine. Yeah, thank you.
Okay. So now I was just discussing about the same thing. So to get to know about the plot, if you have been given some polynomial, to get an idea about the plot from the starting to till now. Yeah.
Sir, can you please explain multiplication algorithm?
Multiplication algorithm.
Yeah.
Okay, multiplication of a polynomial.
Yeah, there is a formula.
Sir, in the lecture, they gave the
Yeah.
complex formula, but as you said in the previous lecture, it is simple multiplication, direct all terms to all terms, right?
Yeah, correct. Yeah.
That's what he's asking about, the complex methodology that was explained in the lecture.
Okay. So see, the multiplication you can directly do that. Like it's not that difficult at all, and will not be given a complex polynomial. You'll be given some simple polynomial for multiplication. First of all, the multiplication, there is a very little chance that they'll be asked. Maximum they can ask you is the divide thing, because at least in the division, at least you have to use some like multiplication is like pretty simple, right? Nobody is going to ask you the multiplication thing. So you just be aware of how to multiply whenever you are getting some polynomial. To use that in a further like courses and all, you should be aware of this addition, subtraction, the multiplication. How do you do that if you have a degree of more than 1 or 2 or 3? But the division, they can ask you just to know about the information. Like they can give you some two different. Let's for example, if you're okay, let's give me an idea. If I'm just dividing a polynomial with a different polynomial, in the numerator part, you have a polynomial of degree 5, and the denominator is also in the degree of 5. So the quotient will be a constant. Is that statement correct or not?
Yes, sir.
The statement is correct, right? If you have a degree same as the numerator and denominator, the quotient will always be a constant. There can be some remainder that I'm not talking about, but the quotient will always be a constant, right?
Yeah. So
this type of problem can come where you have to use like some conceptual clarity should be there. The thing like those, I don't think so they'll be asking the multiplication and all. A multiplication is pretty simple. You just multiply all the term with the other term. You don't get stuck if you're not getting stuck with some algorithm or
this multiplication and basic operations are already learned in 10th class, so that is easy. When a complex polynomials are given and asked to multiply them, then better to use these algorithms.
So
what? Yeah.
So can you take an example of this concept, degree 5 means denominator and numerator have both same degree.
Yeah, it will be having, let's for example, you are dividing x equals to 5 plus 4x4 plus 3x square by some x to the power 5 plus 3x. Okay, if you have to divide it both this function, okay, what should be the quotient you will be getting? The quotient will always be a constant number. Why I'm saying the quotient is always constant? Because see, if you are dividing, let's for example, x to the power 5 plus 3x, and then 3x is 5 plus 4x. What should I multiply here for the first term? The first term? 1, right? If I'm multiplying 1, x to the power 5 plus 3x I'm getting. So this got cancelled. Now I'm left with 4x4 plus 3x square. What should I multiply now? Tell me. To get this.
Division is not possible.
Not possible, right? So there can be a remainder. This can work as a remainder, but the quotient that we'll be getting is a constant. This is what I was saying.
So I think that will be minus 3 or so.
Minus
0x minus 0 of x minus 3x. It will be.
What 0 of x?
Sir, it will be minus 3x.
Okay.
Because the sign will be changed.
Yeah, minus. Okay, this can work as a remainder if you, and this will be your constant. The quotient will be constant. This is what I was saying.
Sir, how to differentiate between function of x and function of y graph?
Differentiation.
No, sir. Differentiate function of x and function of y graphs.
So, sir, one question I have, don't delete the remainder. In this, if I have to find on x equal to infinity, y will be infinity. And x if minus infinity, y will be, just like if it may be plus infinity here because minus 3x is there. But if I have x cube with a minus sign, right? So infinity minus infinity will always be infinity, right? So how positive, negative we can identify? Maybe just take any equation like x cube minus x square, maybe plus 1 kind. In that, how I will find that x infinity, then what will be y infinity? If there are plus minus differences are there. Can you just write equation, sir, for a minute? X cube minus 2x square plus 1, something like that.
X cube minus
2x square plus 1. So in this, if I have to find when x is infinity, y should be infinity. If x is infinite, y will be infinite, sir. Right?
Okay, yeah, now what you are asking?
No, so if I need to plot this graph, right? So I will first find when x is infinite, y is infinite.
Those things, there is no like method to do that, but this is just for the sake of whenever you're plotting to just get an idea regarding how do the plot behave whenever I need to start from somewhere and I have to go somewhere. So to check that, I just need to see that how does the function behave. For that case only we put some random values like infinite, minus infinite, 0 or some 1, 2, some random values to just get an idea about how does the function behave. For this function, if you just want to put the value of f infinite, what do you think? What should be the value at f infinite?
Yeah, it should be infinite.
It should be infinite. Okay. And at minus infinite?
It should be minus infinite.
Yeah, so you got an idea, right?
Okay. And it doesn't have a real root, right, sir? If f0, In this case, it will not have a real root because
See.
1 will be -1. So do we need to think
There
from
is a
that
direct,
angle, or it will
if
make
you want to
sense?
remember that, there is some method also that I can write it here. So whenever you have an even degree, or whenever you have odd degree, so at x tends to infinite, so and one most important thing is your leading coefficient, right? The leading coefficient should be positive. Leading coefficient you are able to understand, right? If you have some function polynomial x minus alpha ka square, some x minus beta to the power n, somewhat like this. This is a polynomial function, and this is your a. A is a constant. A is greater than 0. Leading coefficient is this, right? If this is your polynomial function, okay, so this is your leading coefficient.
Okay.
You got that, right? Leading coefficient, is there any?
The coefficient of the highest degree of that polynomial?
Correct.
Okay.
That's the leading coefficient for you. Okay. And if you have leading coefficient as a positive number, then whenever you have x tends to infinite, you'll be having function as tends to minus infinite. Sorry, plus infinite.
Plus infinite.
Plus infinite. Correct? And whenever you are tending to x equals to minus infinite, you have fx equals to minus infinite. Correct? This is correct, right? Similarly, you can write it for the x tends to infinite and x tends to minus infinite. The function will be infinite and function will be minus infinite.
Excuse me, sir.
Yeah.
When
It
in
will
even
be
degree,
positive infinity
Where?
in even degree, sir.
in even degree. Yeah.
When x
Okay.
tends to infinite, then
Yeah,
fx
this will
will
be,
be
this will be positive infinite. This will be positive infinite. Correct. Yeah. So this is for the leading coefficient. Whenever you have a leading coefficient as a positive number, so this will occur. Okay. You have an even degree. If you're putting the value, this is the standard thing. You can remember that. So or you directly put it in the function. Okay. By putting in the function also, you'll get the same thing. Okay. And if you want to remember that, that's the standard thing that is there. But both are same. But for the leading coefficient an less than 0, what should be the value? If I'm tending to x tends to infinite, what should be the value of the function?
Minus infinity.
Minus infinite. And I guess for the other case also it will be minus infinite.
Yes, sir.
Correct? Similarly, for the odd degree, x tends to infinite, this will be minus infinite, I guess. And whenever x tends to minus infinite, this function will be infinite. Infinite. Like it will tends to. See, and if you are not able to understand, let's take an example. You have a polynomial, a function of a even degree. Even degree is like x to the power, let's for example, this is 8, and the leading coefficient is a constant 5. Okay, and randomly you have some values. Okay, so for these all cases, wherever you have an even degree, right? So you'll be getting, whenever you're putting x tends to infinite, you'll get the function value also tends to infinite, right? This is the highest degree, right? If you have a highest degree of values, you'll be getting a, whenever you're tending to x tends to infinite, you'll get the fx will also tend to infinite because the highest degree has a positive coefficient. You don't have to worry about the other the coefficient of the other degrees, like of the variable, of the x variable. Okay, is it clear?
It's clear, sir.
Similarly, you can go.
I think, sir, in the even degree, when you written when an is less than 0, so instead of x positive, there is x negative. So when x tends to negative, then f of x is negative.
When when coefficient is negative, let's for example minus 5 x to the power 8. If I'm putting x tends to infinite, what should be the value?
It is
whether you're
negative.
putting x equals to infinite or positive infinite, you'll get a negative infinite itself.
I understand that thing, but
he's saying I think you written a wrong statement at x tends to infinity.
Positive infinite you take 4 times.
Here only, right?
Yes,
it's
sir.
Fine.
Yes.
It's correct. Okay. Is this clear to everyone?
Yes, sir.
Sir, I think there are some limitations, like if an is greater than 0, when we consider x power 4 plus x cube plus 1 is equal to 0, then if x is equal to minus infinity, we'll get minus infinity, because minus infinity cube will be minus infinity, and x power 4 will give us infinity. So
I'm not
in
able
that
to
case, we'll get
understand. Which type of function? Can you give
Sir,
me an example? Yeah.
for example, let's consider an is greater than 0, like say 2, an is equal to 2, and let's say 2x power 4 plus x cube plus x plus 1 is equal to 0, plus x plus 1 is equal to 0.
Yeah. So
Okay, now if x is equal to minus infinity, we'll get minus infinity, because um, for x power 4 we'll get positive infinity, and for minus infinity cube we'll get minus infinity, and um, in this case I think we'll get minus infinity.
how did you came to the conclusion?
Because minus infinity plus infinity is minus infinity, I think.
What?
Sir, this is a very ambiguous situation, because we can't say what will be minus infinity plus infinity.
What?
The
Whatever.
minus
Yeah. Go ahead.
So
It
he is
will be
confused about
positive.
with, I think, highest degree with
Yes,
x.
sir. I think he is not able to understand the leading coefficient. The conclusion which is sir telling earlier is based on the leading coefficient.
Yeah, that was totally based on the leading coefficient, right?
Yeah,
See,
sir, but in this situation, we can't predict what will be
okay.
f of minus infinity till we
What
know the
according to
value of
okay, according to you, what should be the value? If I'm putting f equals to infinite, what should be the value now?
Sir, I'm saying for minus infinity.
Here it is infinite. What do you
Yeah,
mean?
it will
Okay.
be infinite, yeah.
At minus infinite, what should be the value according to you?
It will be infinity plus minus infinity plus minus infinity,
Okay,
like
one
that.
thing.
So
If you
minus
are
infinity plus infinity.
okay, one I'm just giving you. So just remember a very large value that you can think of. Can you think of? Let's, for example, x equals to 100 you are taking. Okay, just put the value 100 here and you see the difference. If you are saying that x to the power 4 will cancel out x cube plus 1, then I don't, x cube plus 1, you can just think of 100 to the power 4 and 100 cube plus 100. Will this cancel? Will both the things will get cancelled?
Yeah, that is okay. So I'm saying for minus infinity, for negative x value.
Okay, for minus infinite also, if I'm putting minus 100 here.
Yeah.
Okay, so minus 100, what will the value? This will be a very large value.
Yeah.
Correct. So this will be very large positive value. Correct.
Yeah, that will be positive.
So this is what I'm saying. This will be a very large positive value. The first term.
Yeah.
And what will be this? This will be what? This will be a negative number, but very less as compared to this value.
Yeah, it's less than this one. Okay.
Correct. So this will
Yeah.
always be holding, right? So this plot will go
Then
somewhat
we'll
like
get
this, right?
positive one.
Somewhat like it will cross somewhere, like that depends on the root, but this will go somewhat from infinite to infinite. Okay.
Yeah, yes, I will get positive. Now it's clear.
Okay.
Excuse me, sir.
Yeah.
Sir, have you discussed that how to find the polynomials roots? Because I joined it late.
Polynomial root, I've just discussed you one method. Like the first method that we have discussed, polynomial. See, with the higher degree, it's very difficult to calculate. Okay, with the higher degree, like more than 3. For at least for the 3 polynomial with the polynomial which has a degree of 3, at least there is a chance that you'll be able to calculate it. The first thing is, if you are able to know one factor, the one factor you should be able to know by maybe by hit and trial method or whatever the value, the simple value. So whenever you are getting some polynomial function, you try to see that whether x equals to 1, -1, 2, -2, whether after putting that value you are able to see that those -1, 1, 2, -2 as a factor of that polynomial or not. If you are able to get that, you can just directly divide that factor with the whole polynomial to get the quadratic equation, right? Your quotient will be your quadratic equation, and then from the quadratic equation you will be able to calculate the root, right? For the quadratic equation you already know. Okay. This is the one method that you can think of. The other method, if you have been directly asked to calculate the root, then only this method or the factorization will work there. Or you just have to, from the option, you have to get an idea from the plot also. If you have the plot, if you are able to know the behavior somewhat, you'll be able to calculate it. I don't think so manually anybody you'll be asked to calculate the roots for more than 3 degree. Okay. And even for the 3 degree, if they're giving you, most probably the one factor will be a pretty simple that you can just see and calculate it. The other two you have to calculate it by just divide that to get the quotient and then calculate the other one. Okay. Is it clear? Yeah.
Yes, sir.
Sir, hello.
Yeah.
So the table which you made and just now for even and odd and this one, this will only for like calculating the end behaviors, right?
End behavior
of a graph.
You can get an idea about the start in both, right? How from where you have to start and from where you have to go.
Yeah, that's what from from left to right.
This function, this table, whole table will give you a brief idea, like how does that function behaves in the starting and the end point, if you are taking into consideration. So that you'll just get an idea, right? So for example, whoever has wrote some equation, we got an idea that f equals to minus infinite, it was infinite, and f equals to infinite, also the function value was infinite, right? That means what? This function will start from here and it will go somewhere here, and then it will mean you need to check the roots, the real roots. So there can be a polynomial where you have just, so for this case, what can be the value? This will go somewhat like this or can go like this, right? So there can be a maximum in the even number of roots can be possible here. Is there any possibility that I'll get an odd number of roots for this? If I start from here, I have to go here.
No.
Is there any possibility that I'll be getting an odd number of roots?
No.
It can be possible.
It can be possible, right? How it is possible? Can you tell me?
Sir, only the and like so in like here you have drawn for the second one, it can cross the x-axis now.
Which one?
I mean it can have like.
How? This is what I'm asking.
If the leading coefficient is positive.
Okay, fine. No, leading coefficient, you just skip that, because from the leading coefficient we got an idea that this function is starting from here, it's going here. Okay. Now I am asking you, is there any possibility that I can get the polynomial that starts from here and go here? Can this have an even number or odd number of roots?
It needs one even number to bounce back, so, right? At least.
Yeah, at least, yeah. Even though if you are thinking that it is bouncing back,
only a polynomial with even root will go from positive to positive or negative to negative, right?
Can you repeat the statement?
Only a polynomial with even degree would go from positive to positive or negative to negative.
No, it will not go from negative to negative because you have a even degree, right? So even degree, whatever you want to put that, it will go from
But if
positive
the leading coefficient is negative, it would go from negative to negative, right?
Yeah, correct. I'm sorry.
It
Yeah.
depends on the leading coefficient, but if it is
It depends.
even
Correct.
degree, it will go either positive to positive or negative to negative.
Yeah, correct. It will go from positive to positive or negative to negative. Yeah, I didn't think of the leading coefficient. Yeah, correct. You're correct. Okay, now I'm asking, can I choose, can this polynomial, I have to start from here. I need to go here. Can it has a odd number of roots? Think of and then tell me.
No, I don't think.
Okay. Anyone else? Any idea?
No, because what to say? Wait. Because the degree is even, that's why it will not be odd.
Sir, but in between the roots can be odd, no, sir?
Yes, sir. In between it can have odd
But the
roots.
total will be odd.
The total will be odd.
Even.
Yeah, the total will be even, yeah. Because
But it can have 1, so.
Sir, at origin.
I'm just talking about the real root. You don't have to bother about the complex root.
because degree is even, the number of roots will always be even, isn't it?
Yeah, correct. So, and one more thing is, this question itself is like, if because you haven't went to the complex, because if I'll take into consider the complex root one, so only if I'm taking into consideration the real root, then there can be a possibility. But if I'll just counting whole root, like real plus complex, everything, right, then there is no possibility of getting that. See why? Because in the complex root, see, if you have a degree of some 6, right, so then for sure you'll be having a 6 root. Either this can be a real or a complex. You don't have to like think of that. So only if the degree is a even, for sure you'll be having a even number of roots, right? So let's, for example, this has all this function, whatever the polynomial that I have given you has a this polynomial has a even sorry, it was going, the information is this function is going from infinite to minus for the infinite, for the, it is going from infinite to infinite. Okay, so the leading coefficient, whatever you can think of, the leading coefficient would be positive, and the degree will always be even number. Okay, because if you are taking the odd number, for the odd number it will not be same, it will not be in one direction, it will be going in the different, like in the opposite, you can say the y and negative y. Okay, so let's think of many cases here. If I'm just thinking of the different cases, let's, for example, the roots are in if I'm thinking, okay,
yeah, if there is one root where it's like x square plus 3, right? So it would go to the other side, it would become minus 3, and then the root of minus 3 would be a complex number, and that's when it is not even a root from our perspective.
Okay, what was the example that I gave you? What is the example that you gave? X square equals to?
X square minus 3 is one of the roots, right? X square minus 3 is one of the one of the factors. So that means x value is x
no,
square
this is a
plus
real root. This is a
X
real
square
root
plus
we are getting.
x square plus 3, sorry.
X square plus 3, okay.
Plus 3. So then it becomes equals to minus 3 root, right? Which is a complex number.
For x equals x square plus 3, that doesn't have any real root. It will go somewhat like this, where we'll be having the minima occur. So the function value will always be greater than 3. Okay, so the range for this function is 3 to infinite.
I'm saying the function itself is a polynomial, right? Multiple terms. One of the terms is this one, which makes it like its root as minus 3 root of negative 3, which is a complex number, right? So the total number of factors or roots for an even degree polynomial would be 1 less, because this would not be a real root. That's what I'm saying.
True.
Did I make sense?
True.
What I'm saying is, say for instance, the polynomial is like x minus 1 times x square plus 3 times some other terms, right? Now, if you take that as a polynomial, then one of the roots is minus 3, square root of minus 3, which is not a real root. So we would have to discard it. So now, even though the polynomial was even degree, we have lost one root there. And then our roots become odd. That's a possibility, right? When we are discarding complex roots.
No. But the equation that you have told was having one complex. But the problem complex root happens occur is in the form of some conjugate. So you'll be having two roots there. Let's, for example, you are giving some example. What was the case that you have told?
And take anything, right? One term should be x square minus 3. One of the would be x square plus 3.
But this doesn't.
And then we have other terms, right? Then we have x minus 1.
But the remaining, okay, got it. But the degree, if the, let's for example, if the degree was even number,
right?
So the remaining will be having a even degree.
Yeah. So, but the number of roots will decrease by 1, right?
There are two roots, not the one root. Two complex root here.
Yeah. Okay. So we would lose 2 degrees there.
Yeah.
And 2 roots there. So if we lose 2 roots, then also we end up with even number of.
Correct.
Okay. But still, the possibility is that the number of roots will be less than the total number of the degree. Okay, I got it.
You got it, right? So what I was saying is, even though you are removing this also has a two complex root. But okay, let's skip this. Otherwise, it will be it will take our most of the time. Okay. So what from the conclusion that we have made is, if we have some the even as the even degree, right? So it will start from somewhere here and it has to go here, right? Even if you think of that in the start, the first thing that I've told you, you have a even number of a degree for any polynomial fx. You start from here, you go here, okay, and then you can think of like it is going somewhat like this. If you think of it is going like this, then also you are getting an even number. If think of going like this, also it will be an even number, because 1, 2, and 3, 4, right? Even number, right? Or you can think of, okay, it is coming here and then bouncing back directly, but again, you know that bouncing back has a condition that the multiplicity at that point would be an even number. Correct? So in any of the cases, you are getting what? As an even number of roots, right? Even though you are taking into consideration of complex numbers, the complex number also will be in the form of a conjugate, so you'll be having a 2 roots there also. Yeah, go ahead.
But for like considering the all imaginary numbers, the multiplicity turning points all would be different.
Yeah, so okay, so let's do not discuss about the complex number again. Everything will get messed up because nobody is going to, it's not been taught and it will not be.
Yeah, that's what instructor said, not to consider imaginary numbers in first lecture, week 1.
Yeah, so imaginary, though you don't have, even though you are considering imagining, that also is excluding that it will be having a odd thing.
Sir, mod x can be a person.
Yeah, x equals to mod x. Yeah, this is having a mod x is somewhat like this, right?
Yes.
Oh. Is this a smooth plot or not?
No, sir.
Is this a smooth plot?
No.
No. Right. Okay, what you were asking for the function of mod x? Fx equals to mod x. What was the question? Okay, I think so.
Excuse me, sir.
So, yeah.
Sir,
Question,
can I ask
hi.
something?
Yeah. Go ahead. Whoever was asking.
So, can you move towards that previous slide? So here, the graph which you have drawn, it is crossing the x-axis, so it will have the odd degree.
Okay, tell me how you are thinking.
For example, just examples are like if it is x minus 2 whole square and
X minus 2 whole square. Yeah.
Then x minus 1.
X minus 1. This is already a even odd number, odd degree.
So I can answer that, sir. The things that she's asking is, there was that confusion I also had, right?
Okay.
There is a difference between degree and multiplicity. Multiplicity, if it is odd or even, decides whether the graph cuts x-axis or not the degree.
Yeah,
the multiplicity decides. So she had that confusion, I think.
Is this so? For this function, you have two different root, that is basically 2 and 1, but 2 has a repeated root at 2. So basically, this has a multiplicity of 2, right? And you have x at 1, you have a multiplicity at 1, right? So what does this mean? First of all, this is a degree of 3 polynomial, correct? This is clear. Now tell me, how will you plot this function? Whenever you are putting fx equals to infinite, what do you get? So if you are not remembering anything else, whatever I have discussed here, if you don't remember, just put the value of fx equals to infinite. What are you getting? If you put the x equals to infinite, you'll get an infinite value, right?
Yes, sir. So I was considering it like that, like if there is x minus 2 whole square, x minus 1, and x minus 3,
x minus 3,
and then again x minus, let's say x minus 4. So I was adding up the multiplicities, I was getting the 4. So it will be the 4 degree.
Multiplicity is 5, right? 2 plus 1 plus 1 plus 1. This is 5,
Remove
right?
x minus 4, sir. Remove x minus 4.
Yeah, sorry. Then it will be. So it is an even degree, but it
is
has
an even degree.
Yeah, but it has the odd roots, I guess.
One more thing. The number of unique roots and the number of roots are different. First of all, here you have 2 as a root, as a unique root, 1 as a unique root, 3 as a unique root. But at 2 you have 2, the multiplicity is 2, right? So that's for 2 is the root, right? 2 is also a root, like it's a repeated root you have. If you have x minus 2 ka whole square, if this is a quadratic equation, what do you call the root? How many roots this function has? Tell me. If it is a quadratic equation,
equal roots.
Equal roots,
two equal roots, right? At 2 only, right? So basically you have 2 comma 2 as a root. This is how you say, but you have only one unique root. Unique root means at x equals to 0, the function value is 0. But in term of just saying that what's the root, you say that it has a root at 2 as a repeated root. That means you have the root as 2, unique root, that is fine. But there is a repetition of root. But while counting the number of roots, you will count it twice. Okay? Got it, right?
Sir?
Yeah.
Is it, if multiplicity is odd, then the graph will surely cut the origin?
If the multiplicity is
odd.
Yeah, it will cut the plot. Yeah.
How?
When just take an example, x minus 1 is a straight line. Straight line will cut through, and x minus 2 whole cube is a 3 degree, right? Cubic. and it will be like an S, right? It will go from top to down or left to right.
It will go somewhat like this.
Yeah. So in both the cases, it will cut. But when it is squared, when the multiplicity is even, it will bounce back. So we have to be very, I was also confused with that for a long time. Degree versus multiplicity.
Hey, I don't know. There is no confusion that. First of all, the degree is a different thing.
Right,
So
right. I was mixing that term, sir. Sorry.
Okay. For any function, whatever has been given to you, if you're just counting the degree is pretty simple, right? For whatever the variable that you have been given to you, what is the maximum power that you call it as a degree? But if you have been given the function as a form of a root, okay, let's x minus 2 ka whole square, or x minus 3 ka whole cube, x minus 4 ka 5, okay. Now tell me what's the number of degree here? The number of degree is simple, right? 3 plus 2 plus 5, the 10 is the degree. But the multiplicity of 2, the multiplicity, how they'll ask you? They'll ask you what's the multiplicity of x, the root 2, right? What's the multiplicity 2? For 3 it is 3 and for 4 it is 5. Whenever you are plotting the curve, as you have an even number, you already know that this function will bounce back. It will not cross the x-axis. This function, if you have an even odd number, it will cross, and again you have an even number, odd number, it will cross. So what's the confusion here till now? What's the confusion?
It's yeah, you said it right, that if it's an even, it will bounce back, and if it's an odd, it will cross the x-axis. But my question is, like, is it if multiplicity is odd, the graph will cut the origin, like 0, 0? Have we that
origin? Okay, 0, 0, you can't say that. That you can't say. We are talking about so there is a difference between cutting 0, 0 and cutting the x-axis.
Yeah.
Cutting x-axis means that point is a root or the x-intercept. That means that point that is cutting at that particular point. Let's, for example, x equals to 3. So this x equals to 3 is simply like at x equals to 3, the graph will cut at x equals to 3. It is not crossing 0, 0. It's a simple, whatever you have read till now, y-intercept or x-intercept. X-intercept is all those points, all those values of x where the function is cutting the x-axis. If the function is cutting the x-axis, that means what? At that particular point, if some point is here, that means what? The y value is 0, right? Y value is 0 means what? This is the root of a function. If you are getting a point here, that means what? The x value is 0. That means it's the y-intercept of a function. That's simple, right?
So there is no relation between multiplicity and origin, cutting the origin.
No.
Okay, got it.
Sir, in lecture, that's why we call the multiplicities of zeros. That will distinguish between degree and multiplicities.
What?
In a lecture, it says the multiplicities of zeros. That means where x is 0, y is function is 0, then it's called multiplicity, right? Zeros of multiplicity.
Zeros of multiplicity.
Yes, sir. Like multiplicities of zeros.
What he's saying is multiplicities of zeros, right? So x minus 2 is 0. Right? That is a 0 because that's a root.
Okay, so
multiplicity of roots or multiplicity of zeros. That's
he just flipped that.
Oh, okay, got it. So multiplicity of zeros, that means at 2, for 3, for 4, whatever the zeros are there. Zeros means the root of the equations. Okay.
Yes, sir.
Yeah. This is what we were discussing for the multiplicity of all the roots at particular point. So this is the best thing that we have discussed. This is the equation. Mostly they'll ask you this type of problem where you will be given this type of plot. The polynomial will be given to you. Okay. And then you can be asked to so many different type of things, like what is the multiplicity of root 3? What is the multiplicity of root 3?
1.
So there's no issue in that, right? Similarly, you can calculate the multiplicity. You can just see and tell what is the multiplicity of each of the zeros or the roots of the polynomial.
Once can you discuss about increasing and decreasing?
Okay, increasing and decreasing functions, like, let's see how is that function behave. Like, if I have a polynomial somewhat like this is going like this. Let's, for example, this is 1, this is 2, and this is -1. Okay, if I'm just asking you, is this function increasing? First question. The second question is this function increasing in domain 2 to infinite? Is this function increasing in domain -infinite to -1? Is it decreasing in 1 to 2? How many of the options are correct? How many of the options are correct? Only 1, only 2, only 3, only 4. It's like all the 4.
Only 2.
Sir, only 2, I guess.
Only 2 is correct, right? So see the first option. How many of you are saying that the first option is correct?
So how would we define that? That's my problem. I cannot even picturize that one. Because
sir, how we can conclude the overall function is increasing or decreasing?
Right.
Okay. So first of all, what do you mean by increasing function? Increasing is simple, like whenever you are, so increasing is basically if you are increasing the, so for any function y equals to fx, okay, for fx equals to any function, if you are increasing the value of x, okay, let's, for example, I just took it, you just have to take 2 values in the domain. Okay, so first example, okay, I'm just discussing the second example. Here it has been given in the domain 2 to infinite. So here it is 2, right? And this is infinite. In between 2 to infinite, I just took 2 values. Let's, for example, I took 3 and 4. So at the function value at 3, what is the function value at 3? This height will be the function value, correct? This is f3?
Yeah, that's right.
This is the y value, right? And for f4, what should be the height? f4, this is the y value for 4. Now for any increasing function, whenever you increase the value of x, the y value should also increase. Okay, so let's, for example, if you are taking 2 values 3 and 4, this can be written as x1 and x2. If x2 you are taking as a greater than x1, the fx2 should be greater than fx1. This is how you define, and if that is holding, you can directly say that this is an increasing function.
So can we say that a tangent is positive, then it is increasing?
Yeah, that also you can say that if the tangent is positive for all the value, like you can't say at some particular value, it should be positive for all the values.
Sir, in the option 3, minus.
Sir, option 3 is also correct, no?
Yeah, option 3 is also correct. Yeah, so first of all, if whatever I was defining the increasing function, is it like now you're fine with that? Are you able to understand the increasing function?
No, the option 4 should not be correct, right? Between 1 and 2, it is going.
I'll discuss the options.
Yes.
I'll discuss the function. First of all, the increasing function is clear, right?
Yes.
Sir, can you explain it again?
So what you are saying, sir, is we have to move on x-axis from -infinity to positive infinity, and see the values in there. If it is increasing all the time, then the function is increasing, right?
Correct.
In this case, it is falling down in between 1 and 2, so it is not.
It is not in. Yeah, it is not. If I am giving you a straight line, is this an increasing function?
Yes, sir.
Yeah,
sir.
It is always increasing. You just take any value, random value, x1, x2, x3. You'll see that at x3, the function value is maximum. At x2, the function value is lesser than that. And then at x1, the function value is even lesser than that, right?
Yes.
Correct?
My confusion was whether we start from positive to negative axis on the x or negative to positive. So
no,
that's what it was always negative to positive. So
it
if
will
you move
always
in
be
that
negative to
direction,
positive. Yeah, it will always be negative to positive.
oh,
Okay, for increasing function. So as in this case, the first option is the function increasing and there is no domain been given to you. If the domain is not been given to you, what does that mean? Like you have to check from minus infinite to infinite. So if you'll see that from minus infinite till -1, you can see that this is increasing. That is fine. Till here it is increasing, but now you can see that from here it has started decreasing, right? The function for increasing function should always increase. Okay, so that means this is violating from here. What can be the value? Let's, for example, this is some constant value k. From k to 1, this is not holding our condition of an increasing function. That's why the first option is incorrect. Now you can see that in the second question, is this increasing from 2 to infinite? Now you can see that from 2 to infinite, the function value is always increasing. Now you can say that the second option is correct, but the first option was incorrect. Are you able to understand that?
Sir, can you please explain first option once again, please?
Yeah, in the first option, what I was saying is this function increasing? Is this function increasing? That means for all the domain, for all the values for which the function is defined. What do you mean by domain? Domain is a function for all the values where the function is defined, correct? Domain is what? What is the domain of a function?
All the possible values for which function.
Yeah, all the possible values.
For x.
For which function
Values
will
of
have a
x.
unique value.
Yeah. For which function is defined, right? For which function is defined. Correct? So here, I just told you for fx is increasing. I didn't told you about the domain. That means what? If I am not saying anything about the domain, that means you have to take into consideration from minus infinite to infinite. Because from minus infinite to infinite, the function is defined. You can see the plot. From minus infinite, it is holding from minus infinite, going here, coming here, then going to the plus infinite. That means this function is defined for all the real number, right? So the domain for this function is R. But you can see that this is not increasing always. This is increasing from minus infinite to this value, but now it has started declining. So that's why the first option is incorrect. In the second option, I just bounded the domain. Now you have to just check it from 2 to infinite. Now you can see that from 2 to infinite, is the function increasing?
Yeah, that's right, sir. It's
That's
increasing.
right? Correct.
Yeah.
Now
Yes,
you'll see
sir.
that in the third option, is the function increasing in domain minus infinite to 1 minus 1?
Yes, that's also
That
right.
is also correct.
Yes.
Now you'll see, is the function decreasing in 1 to 2?
Yes,
No, sir.
not
Decreasing
always.
then
Decreasing
Not
and then
always.
increasing.
Decreases
Yeah,
then
it is decreasing, then it started
But
increasing. See, right? Here, let's, for example, this is some value L. Okay, so it started declining and then started increasing, right? If you would have asked to calculate the function is increasing from this domain L to infinite, is this a correct statement or a wrong statement?
A wrong statement, sir. It's decreasing.
No, it's increasing, right? This is L, right?
Oh,
This
that is L.
increasing.
Then it's, yeah, that's right. Sorry, I got confused
Okay.
with that. Yeah.
And the most, okay, so this part you should be knowing. There can be some option where the polynomial can be given to you and then the plot will be given to you. Just by seeing the plot, you have to check whether the options are correct or not. Okay, and this is much, I'm just putting 5 star. You have to know this. Okay,
Sir,
if
that
you have a
means
doubt, you
all the
can just
linear,
ask me.
excuse me, sir.
Yeah.
All the linear functions are increasing, sir. Then
All the linear functions are increasing. That depends on the slope. If you have a linear function like this, this is a decreasing function.
okay.
So
Yeah.
only for linear functions we can say about the whole increasing or decreasing. Only for linears.
No, there can be a function like this. That is
x
like this.
cube would be increasing, right?
Yeah,
X
something
cube.
like this.
Yeah.
Okay, that function is what? That function is also in the form of some half parabola. that is also increasing function, right?
So if you take complete parabola,
What?
Complete parabola, it is not.
Complete parabola, it's not. Yeah, complete parabola is not. Even if you are taking x cube also, x cube, this is also increasing function in its domain. But here you just have to know a brief idea. You will be taught everything in the 5th lecture again. But what I am saying you, this is the very basic thing that you should be knowing. How, if you have been given the plot, at least you should be knowing this function is increasing or not. Because you have been taught regarding the polynomial function, right? If you know about the polynomial function, how to plot this, at least this is the minimum thing that you should be knowing for any polynomial function that has been given in the sum of plot. You should be knowing that this function is increasing from this value to infinite, or this value to infinite, or this is in minus infinite till at least this value, this function is increasing. This much at least you should be knowing. If you have any doubt, you can just ask me regarding that. And this is an important portion. That's why I just came in my mind. I'm saying you. Is this clear to everyone?
Yes, sir.
Okay.
Yes, sir.
Yeah. If you have
Sir,
any other doubt,
I have a doubt.
Yeah, go ahead.
So in assignment, they gave two graphs and asked us to determine whether the graph is function of x or not. So how to differentiate?
Function of x or x or not?
Yes, sir. They gave two graphs.
Function of x. Okay. Did they ask you about which of the following is a function itself or not? Is this the question or what?
No, sir. Like they gave two figures, sir. They have graphs.
Okay. Can you tell me the question number?
Like it is in graded assignments.
Hey, graded assignment.
Yes.
I'll discuss it tomorrow after Tuesday.
No, sir. But similar question once you can explain.
But the general concept itself is that what he's asking is if they have given a polynomial and they have given a graph, how to map and see that the polynomial is actually fitting that graph, right? So
I guess so. The question would be somewhat the polynomial would be given, and then you have to check whether this is a function itself or not. Is this the question? Okay, tell me the graded assignment.
No. They have given the polynomial and they have given the graph. We have to select which graph actually fits that polynomial, right?
Okay.
So what we have to do is we have to find the roots and then see whether it is fitting or not fitting, right? Whether it is meeting all the criteria.
Tell me the question number. I'll just check it once. What is the question? At least I should be. Are you able to see my screen, right?
No, sir.
No, sir.
Okay, 1 second. Is it visible now?
No, sir.
No, sir.
Now you can see, right?
Yes, sir.
Yes, sir.
Okay. Can you tell me the question number?
Question 9, sir.
In practice assignment, question number 7 is also very similar.
Okay. Practice assignment, question number 7, right?
Right. It's very similar. It is not exactly the same, but it is very similar. So what they have done is they have done the division of two polynomials, and then they say which one meets the requirement of that polynomial, remaining polynomial, remainder.
Okay, let's. Question number 7, right? Okay, is this the polynomial, the Rx be the polynomial function which is obtained by the remainder? Okay, so Rx is a remainder function. Remainder function after dividing this 2x.
And what they are asking is map this polynomial or whatever is that to the graph, right?
Okay.
Similarly,
Okay.
we have to make sure that whether it meets our so if it's a longer polynomial, maybe he is having graded assignment a longer polynomial wherein he has to map this.
But this is quite simple, right?
This one is
Also, in the
simple.
graded assignment, he did not give any polynomials. So he just gave the graph and asked us to whether the graph represents the function of x.
Okay, so then you are to just know that whether this is a function or not. There is a. How do you define function? First of all, tell me what do you mean by a function?
For meeting this requirement, it's a horizontal line test, right? If he's saying that, well, a function is where for each input there is a unique output. A function, it's not a function if for the same input value it gives two.
It is a function.
Yes.
Is this a function?
No.
No, sir.
It's a function, sir, because horizontal line it passes the test.
Horizontal line
It is vertical.
It is for 1 function for horizontal, I guess.
Yeah, for horizontal line test is for 1 to check whether the function is a 1 or not.
Okay, got it. I mixed it. Okay.
Because here for single value x, you are getting two different values, right?
Yes, sir.
Correct. So this is how you can check whether the given thing is a function or not.
Okay. Yes, sir.
Got it right?
Yes, sir.
Yeah. I guess this is all we have discussed, right, in the starting weeks.
Yes, yes.
So this is not that difficult. You can check it. I guess we have discussed it somewhere. This we have uploaded it also. You can just go through that. I guess where is that? So we have discussed all these things, right? The type of function and all those things in the first week itself. So from there you can get an idea. This is pretty simple, right?
Yeah. Sir, is this uploaded? All you told it is uploaded already.
It must be there on the live session slides.
Can you share all these slides in the chat box?
Chat box, yeah, see, this will okay. In the 5th week also we'll go through again all these things, the vertical line and the horizontal line test. Okay, basically the vertical line test, whether the relation that has been given to you is a function or not. Okay, so these all things will come to know again, but this has already been taught in first week also, right? Okay, any other doubt that you have from this week, you can just ask me.
Excuse me, sir.
Yeah.
For the same question number 7, I got the remainder as x, but I'm confused with the A and B option.
Which one? Practice assignment, right?
Yes, sir. Question number 7.
Okay, what have you got in the remainder?
X, I guess.
X. What did you get? X?
Minus X only, sir.
Okay, minus X. Then what's the
No, sorry,
okay.
plus X. Sorry, sir, plus X. Sorry.
Okay, even though you got plus X, how will you represent the plus X? Plus X is a remainder.
Cannot be, right, sir? It cannot be remainder because that is the same degree as the denominator, so it cannot be the remainder.
Yeah, that can't be. Okay, first, okay, let's divide it, then we'll get an idea about that. But if you are getting x, y equals to x, then what's the problem? I don't think so. What's the issue here? If you are getting x, so first of all, you will not be getting the x as a remainder, first of all. And if you are getting, you'll get some constant right here.
Remainder is -2.
Okay, remainder is -2. If remainder is -2, then
I think remainder is 4, and that is why the graph
Yes,
is.
sir. Remainder is 4. Yeah, sorry. Remainder is 4.
Okay, when the remainder is 4, how will you plot x, y equals to 4? How do you plot y equals to 4? Which are the line where you will always get y equals to 4?
Horizontal line passing at 4.
Whenever you have to, yeah. So you just have to, whenever there is a y equals to some constant, or y equals to some constant k, or x equals to some constant k. If you have y equals to constant k, the line will be parallel to x-axis, Whenever you have x equals to k, that will be parallel to y-axis. Okay, so let's, for example, you have y equals to 4. It will be somewhat here, y equals to 4, parallel to x-axis. Now see, if you just take a point, this is 4. Okay, so this will be what? 4, 4, because you already know that y is always 4. For this line, always if you take any point, y will always be 4, right? And x will vary. Okay, is it clear now?
Yes, sir. So remainder is actually y.
What? Remainder is actually y?
Remainder, I got remainder as 4, so it is y.
Remainder.
So she got remainder as 4, and she's asking whether y is equals to 4. Is that how she should equate? I think.
See, Rx is what? Rx is equals to 4. Okay, so your plot should be like this. If you are taking Rx as a y-axis, this is Rx equals to 4. I was just saying y equals to Rx. If you don't want to say it R equals, like, you just say as Rx as a y-axis, and this is x-axis. So this is the plot you should be getting.
Yes, sir. Got it. Thank you.
Got it, right? Okay. Anyone else has any other doubts in any whole week or 4th week?
I have
doubt.
Sorry,
yeah, go ahead one by one. Yeah. Go ahead. Are you able to hear me?
Yes, sir. I thought that other person was going, so I kept
Okay.
quiet. But I would go ahead. Can you explain me about the SSA? I know the concept is very simple, but when they are asking for determining the C value, the constant value in that polynomial, I'm getting stuck and confused.
SSE, or what did you ask? Sum of
Yeah.
a squared error?
Yeah, sum squared errors. Yes.
Okay, sum of a squared error.
I know the concept that, okay, we have to take x and then y, and then we have to determine the new y, and then we have to
but
take the
this we'll discuss again in the revision session that I'll be taking. So
okay.
If you have the revision session, I'll be taking this whole concept. I'll be explaining all those things again in the revision session. That will happen in the coming Wednesday or Tuesday, Thursday. It will happen. Okay.
Okay. Thanks. I will
yeah. So if you have any doubt from this week, you can ask.
Sir, I have doubt regarding the assignment submission.
What?
like on 25th we have this one. So like for week 5 can't the submission like weeks.
25th, okay, I'll give you an idea. 25th is your quiz paper. You'll be only getting from week 1 to 4. Okay, you have some
Yes, sir.
10 to 11 questions. Okay, you'll be having each week will consist of some 3-4 problems. Okay, 4 weeks we have some 12 problems, 50 marks of quiz. Okay, the problem will be MCQ, MSQ, and NAT. NAT will be having a higher chunk. Okay, MCQ and MSQ will be of equal weightage. Got an idea, right? All the problems
Yes, sir.
will be simple to moderate. None of the questions that, as far I have seen the paper, none of the questions was difficult. All the questions was easy to moderate. Okay, out of all those 12 questions that was present there, all the questions are easy to moderate. And the revision session, I'll give you an idea also, the important portion that you should be going through. Okay.
Yes, sir. But like the week 5th graded assignment submission date can't be extended, sir.
When is the week 5th deadline?
Yes, sir. Like it is 28th.
28th.
It's
28th is after quiz, na? So yeah, that is, you have to manage that. That is after 25th, so you have 3 days, right? You can do that. There's no problem in that. Because if the deadline will get extended, because that is a fixed schedule, right? If we'll extend it, there is a possibility that it can be extended also, but as of now it is 28th only, right? And all the schedule has been fixed already before the starting of the term, so that most probably it will not get extended, but you have some time after the quiz also, some 3 days.
Like from 27th I have semester exams.
Okay, but yeah, but people are managing. Like there are so many people who are working, but they are managing. So I guess it's manageable. You can, but we'll see that after the quiz whether if it won't be that feasible. We'll see that, like whether to extend or not. But as of now, it is that. Yeah. Anything? Any other doubt that you have? Anyone? And the TAs will be taking some sessions there. They will discuss the previous term paper. Those sessions also you can attend. I'll also join there and I'll try to record those sessions for sure. Okay, so at least those 2-3 sessions that will occur this week, I'll record those sessions also. There they'll be discussing. Yeah.
So how much time will you get for quiz?
You'll be getting 1 hour. 1 hour.
1 hour for
all subjects.
4 subjects.
Hey, not all subjects. 1 subject.
For 1 hour. That means 4 hours.
If one maths. What?
I'm not getting. So 1 hour for each subject means will they give 4 hours for us?
For maths, I can say I'm not aware of the other courses here. So if somebody has, many of you would have written, right, qualified, that person would be the best one to answer you.
Qualified was 5 hours for all 4 subjects.
All 4 subjects 5 hours, right? Yeah. And you have to sit in one sitting, right?
Yes, sir. Minimum submission time is 3 hours, sir. After
yeah. You can't go. Yeah. This is how it works. Yeah.
But sir, all the 4 papers would be available for the entire duration. We can answer any order.
Yeah. It will be given. Yeah.
Okay, that would be good.
I think so. In my past experience, the time is usually sufficient, but so I've never had any issues with
Yeah, the time would be sufficient. That is for sure.
Pretty sufficient, yes, sir. Yeah, I agree.
The only thing is you have to sit for that. If you have taken 4 courses, you have to sit for that 4-5 hours. The questions, maths one also paper I have seen, the papers was as much on the easier pace, at least the lesser, like easier than your graded assignment. If somebody has solved all the graded assignment, you'll be able to score it very nice. But if you have to copy it from somewhere, then you may struggle. But yeah, if you have copied also, and then from now you have some time, 7-8 days, you can just because I was going through the graded assignment marks from the plot that I have got, like it's like most of the you have copied from somewhere the marks, the answers. So you have time, you can practice that graded assignment, and at least the previous term 3 papers you should be practicing. Okay, if you do that, there is a very high chance you'll be getting more than 70-80 marks, percent of marks. So attend those TS session also, 2-3 session that will occur next week. Attend the session, the revision session that will happen next week. I'll be discussing some of the questions and the important concept that you can't leave. Okay, and then the previous term paper also will be discussed next week. Okay.
So previous term papers will be provided.
Hello.
And all these will be recorded, right, sir?
Sir, where we can get the previous year questions?
So in the tomorrow's session, one previous term paper will be discussed. The TS session, I guess tomorrow or day after tomorrow, that is occurring. They'll share the paper at that time itself. Okay.
Can we get the PDF files?
Yeah, you'll be getting the PDF itself.
Okay.
Okay. Okay, so is it done? If you don't have anything, we will just meet again, I guess, next week for the revision 1 session. Okay.
Sir, what will be qualifier timings, like morning or evening?
Timing, I'm not evening.
I think you'll see it in your hall ticket. It'll mention what time's allotted to you.
Are you so how many? So anyone who is going to so you'll be going. So your hall ticket has already came, right?
No, sir, not right now. But I think when they will issue it, you will see that information.
I guess. Okay.
But I don't even know the address of the center.
You'll get to know from where you are.
In Madurai, right.
Okay, Madurai. So in the Chennai too, there are so many places. You'll be getting the exam center very nearby one.
Like
I think it will be before also.
Sir, we have previously opted for 2 cities. In that 2 cities, they can give us any one of them, no?
Okay, I am. Those things I'm seriously not aware of. Maybe the team generally puts it those things. So.
Sir, somewhere I saw the this qualifier exams will be connected at TCS Center.
TCS Center. You'll get to know about that in the coming 2-3 days, most probably. Okay. Yeah. So anyone is having any other doubts?
Can we look at other ways of solving for roots, sir, for cubic?
There is a cubic formula, but that is a very complex thing. We have to make a derivative of it. We'll get x minus 3 b by 3a is equal to x, like that. We have to solve it. It's a very complex process.
What? Can you repeat
I
that?
have that derivation. So there is a cubic formula for that. We have to take x is equal to b by 3a. We have to take derivative of it, and we have to substitute x minus b by 3a in the